All right, we're talking 2020 version of the National Electrical Code, and we're talking 240.87. 240.87 is for arc reduction. That's where the focus was. It was introduced in the 2011 version of the National Electrical Code. And remember, the very first version focused on circuit breakers without an instantaneous. We morphed that into 1200 amps and above. Okay? And then in the 17 code, we introduced arcing currents and instantaneous. So here was what was going on. As part of the 2017 code, when they introduced the instantaneous, there were some manufacturers and some engineers saying, listen, all I have to do is, my instantaneous is adjustable down to 2 times. So that meets the requirement because the contractor can just roll down the instantaneous and roll it back up again. And that would be ungood. But there was nothing in the 17 code that said they couldn't do that. So the 2020 code said, okay, we understand this is going on in the industry. We've had complaints, we've had questions. We've had some of those people say, look, we have this energy reduction maintenance switch that has a button, it has an indicating light, and then this guy says he's just going to roll down instantaneous, and it's already built in, and it's free. And that's an easy sell when something is free. But inspectors were complaining that doesn't meet the intent of the code, but we can't enforce intent. So in the 240.87 section in the 2020 code cycle, they didn't change the adjustability. The 1200 amp number is still there, whether you have the door cover on or not for the locking, based on 240.6 and all that jazz. If it can be adjusted to, just like we have over in 230.95, then you're going to have an arc reduction technology, 1200 amps and above. Now, in the documentation, so one of the discussions at panel 10 was that, look, I can employ this technology. I can put the arc reduction maintenance switch. I can put differential relaying. I can do all these things. But if it doesn't activate on the arcing current, if none of these activate on the arcing current, or the one that I picked doesn't activate on arcing current, then it's not doing you any good. So we have a documentation requirement now in 240.87a. And the new sentence they added says that you have to document and you have to provide and demonstrate that the method chosen to reduce the clearing time is set to operate at values below the available arcing current. Now, it still doesn't tell you which value. Is it the maximum arcing current? Is it the minimum arcing current? Regardless of that, though, you have to demonstrate, you have to show, and it says documentation shall be provided to demonstrate. So you don't have to actually demonstrate it. You just have to have the documentation to show that, look, here is my arcing current. Here is my set point. My set point is less than my arcing current. It will activate on that arcing current. And you're going to use IEEE 1584. Now, the other problem that you have is if your fault current is greater than, bolted fault current is greater than 106,000 amps, you do not have a way to document that any of these technologies will activate on the arcing current because you can't calculate arcing current. Now, what you can do is calculate the arcing current at 106,000 amps. And if that value will activate the technology, then you know that any higher bolted fault current will generate a higher arcing fault current, and those will also activate this technology. So the best you can do is calculate your arcing current at 106,000 amps. Compare that. If it works, then you're golden. If it doesn't activate your technology, then you're going to have to employ another technology to show that arcing currents at 106,000 amps will activate those technologies. That's the only way to get it done. Because you can't calculate arcing currents for bolted fault currents greater than 106,000 amps. It's not impossible. No equations exist. Now, the method to reduce the clearing time. One of the following means shall be provided and shall be set to operate at less than the available arcing current. In 5, what they did, now remember, so in the parent text of B, they said, one of the following means shall be provided and shall be set to operate less than the available arcing current. So in A, we said you have to document it. In B, you've got to pick one of these that will activate at the arcing current, or is less than the arcing current. And then the other change they made is in 5 for instantaneous, to address all of those cases where they were saying, look, that breaker has an instantaneous. All you need to do is roll it down and roll it back up again. Sorry. Temporary adjustment of the instantaneous trip setting to achieve arc energy reduction shall not be permitted. And the opponents to this said, look, you can't tell people to do that. These circuit breakers, the adjustments on circuit breakers are not the same between manufacturers. How can you make sure that the electrical worker is moving the right dial? How can you ensure that they're going to put it back to where it was? This could be a selectively coordinated system. Article 700, they could screw up the selective coordination. And then if you look in NFPA 70E, that's not a permitted work practice to be making adjustments of the overcurrent protective devices in the field. So it violates a lot of things on a lot of levels. So they specifically said, look, you are not allowed to temporarily adjust that instantaneous trip. You can use the energy reduction maintenance switch, which is a switch. You put it in the mode, you take it out of the mode, you got an indicating light that tells you you're in that mode. But you can't just say, I'm going to roll down the instantaneous and roll it back up again. So I guess the big changes here, all of these technologies have to respond to an arcing current. We still don't have a definition of what an arcing current is. And we don't know if it's the minimum or the maximum arcing current. Still haven't addressed the greater than 106,000 amps bolted fault current issue. But we have ways to deal with that. And you can't temporarily adjust your instantaneous. All right, so another thing that they did with regard to 240.87 in the 2020 version is they added a 240.87C as in Charlie, which is titled performance testing. Now the roots for this one comes out of 230.95, and 230.95, remember, is ground fault protection of equipment, and 240. I think it's 13. Yep, 240.13 is ground fault protection of equipment. So if you look at 230.95, which 240.13 points you to. So if we go to 230.95, and this is basically how the discussion went, we said, look, we have this requirement when you install a ground fault protection of equipment as part of 230.95. We have setting requirements. We have requirements around fuses, and we have performance testing. And we tell you that the ground fault protection system shall be performance tested when first installed on site, period. But here we are, and that's equipment protection. Here we are in 240.87, which is all about the electrical worker. And I don't have any performance. I don't have to show you and prove to you that it actually works. And remember, in 240.87 in the 2020 code, there was this additional emphasis on the fact that we want to make sure that all of these technologies respond to arcing current. There was even a debate at the panel with regard to, does it have to respond to arcing current at this equipment or at the downstream equipment, etc. So we went back and forth with that, and what we settled on was 240.87 requiring an evaluation with arcing current in the parent text, in the documentation, and then they said, look, when you install this stuff, you better make sure it's working. Because if you're doing differential relaying, you're going to have to look at the polarity of the CTs, make sure you've got them installed correctly. If you're doing zone selective interlocking, you could have a complex system where you have all these different zones that have to be looking for each other. You've got to make sure that that complicated system is working. If you're using the arc reduction maintenance switch or an instantaneous. So in any case, and now since it's 1200 amps and above, you obviously in 230.95, if it's service equipment, In 23095, you're going to have to do testing anyway with regard to the ground fault protection of equipment, and that requires primary current injection testing. So I would argue and make sure that who is ever doing that testing does double duty and gives you a report that these technologies are working fine as well. So if I'm primary current injection testing ground fault protection of equipment, I could set the instantaneous on this very low and inject enough current in here to make sure that it opens the overcurrent protective device. There are different things that I can do to prove these technologies are working at the same time that I'm doing my GFPE testing, probably by the same people who are doing the GFPE testing. And if they can't, if that organization that you're using can't do both of these, go find somebody who can kill two birds with one stone for you. So you're not paying two separate entities to come in and do some testing. So in any case, that was another big change for 240.87. So that is basically the 2020 requirements for 240.87.